I'm Matthew Goldsby, part of the coated M2A at Swansea University, and I'm in my final year of my engineering doctorate. My doctorate is looking at zinc and aluminium coated steel and the use of these galvanised coatings. So my sponsoring company is Tartar Steel Colours, which is based up in Shotton in North Wales. And I'm looking at zinc and aluminium coated steel with different alloying agents to enhance the performance of their coatings. One of the additions talked about previously is magnesium, and this can be incorporated into the zinc and aluminium to help with the corrosion performance, which will lead to a thinner coating being applied, cost savings in raw materials and processing costs, as well as maintenance costs in the future. Alternatively, the better corrosion performance gives a longer component lifetime, so we have an improved and more marketable product, won't need to be replaced as often as others. It's not the case that this will simply phase out the use of other alloys, because different alloying compositions respond in different ways depending on the sort of environment they're used in. So you have to factor this in when assessing what the magnesium-containing alloys will bring as compared to just the zinc and aluminium. So some of my recent work with the zinc, aluminium, magnesium alloys was the use of the Parisian testing, which is basically an accelerated cyclic testing of real-life atmospheric conditions and how this can affect the alloys. So the results were really interesting, so I broke down the different variables to get a better understanding of the effects each were having. What I found was that the alloy was more resilient to sulfate environments than conventional understanding suggested, and this sort of exposure you would often find in the typical industrial setting. Because the protective qualities of the alloy were maintained in this type of environment, it opens up the possibility of expanding my industry sponsor's product line, meaning the alloy could make its way into the construction market after some further testing. The global construction market is estimated to reach $8 trillion by 2030, so the information that can be taken from my research gives the company a great opportunity to exploit over the coming years. So I think this shows how work done in the engineering doctorate can not only help you in the academic world, but also in the industry world, and provide a link between the industry and the academic, but a real change that can bring to the industry that you work with.